This is video number 28. It does say build number 3 and 4 first. So you should already have done the dots. You should already have done the lines. And then you build the molecule with the model kit. And then watch this to see how to sketch it. So if you haven't built a model yet, do it before you return to this video. This is the structure of the NH3 molecule. It's ammonia, found in cleaning products in your home. It's not flat. You can see I can put a pencil underneath without touching this central atom. So this is a structure that's called a pyramid, and we need to show its three-dimensionality on the two-dimensional paper. Chemists have developed a convention for showing three-dimensionality. We need to get out of the plane of the paper to do that. So I'm going to look at this molecule from this angle here, and I'm going to choose the plane of the paper to be right here, including these two atoms. So here's my ruler, and I'm going to line it up with these two atoms here, this hydrogen and this nitrogen. And imagine cutting through the molecule just like that, as if it were a knife. If I do that, I'm hoping you see this hydrogen will be closer to me. It's not in the plane of the paper, it's closer to me. And there's one that's behind the plane, behind the cleaver. So, this is how you draw that on paper. So here's a nitrogen. Put a nitrogen. This hydrogen that's in my left hand is in the same plane of the paper. So I just draw a hydrogen with a normal bond straight line between them. This hydrogen is up out of the plane of the paper. I use a wedge, usually shaded, to represent something, to represent an atom that's up out of the plane of the paper. The last hydrogen goes back behind. If this right here is the plane of the paper, then this hydrogen here is behind the plane. Behind the plane. To represent that, I do a dashed line. It recedes into the distance. And there it is. There's three hydrogens. One in the same plane, one out of the plane, one behind the plane. To a chemist, this picture here represents a three-dimensional structure that looks like this here. It's a pyramid. It's 3 feet on the bottom and the nitrogen on the top. Number 4, methane, comes up with this model, and this is the most famous shape in chemistry. It's called a tetrahedron. The tetrahedron has really nice symmetry. You can see from the shadows on my paper, it's really cool. So I'll show you how to draw this shape. First, I'm deconstructing, taking out 2 of the atoms, doesn't matter which 2. But then you'll be left with something that's quite simple. It looks bent. And since it has only 3 atoms, this is coplanar. It's flat. I can draw on the paper what I see in the model. So, for me that means carbon right here, hydrogen up, hydrogen at an angle. It's not 90 degrees. Don't draw it square. It isn't square. Match the angles in the model. Now, here's a third hydrogen. I'm hoping you see this is up out of the plane, and therefore I'll use the same technology I did before. A wedge will represent an atom up out of the plane. Where do I draw it? If you had an imaginary angle bisector, this atom is right on the line, or right on the plane, that bisects this angle, cuts it in half. So I go here, I cut this angle in half, here's my wedge, and here's a hydrogen. So that's 3 out of 4 of the hydrogens. The 4th hydrogen does go in the back. So if this is the plane of the paper, that hydrogen is behind the plane. So again, I use the dashed line to represent that hydrogen behind the plane. In reality, it's right behind the first hydrogen. It's right behind it. So I won't draw it so it's invisible, but I will draw it here so it's pretty close on the paper to this other hydrogen here. These two are on the paper close together because one's right behind the other. As you can see, the true picture looks nothing like this flat square thing here. The true picture is beautiful. Learn how to draw a tetrahedron. So now you should have enough skill to use various models to do the last 3, 5, 6, and 7. And you'll start with the dot structure, then you'll do the line structure, and then you'll do the molecular model with its 3-dimensionality and try to draw the true shape, the beautiful shape of the molecule.